Good morning, students. Today I welcome you all to the lab program explanation of Computer Graphics and Visualization Lab. And the program that I'll be explaining is the program using OpenGL function to draw a simple shaded scene consisting of a teapot on a table. And for this, you have to use some properties of light source, and as well as the position. Okay, so this is what exactly the program I'll be teaching today. Now, before going to the actual topic or the program, let us understand what exactly the teapot is. A teapot, also known as Uttaha teapot, is a very standard uh, 3D computer model or a geometrical model, and it is one of a very standard reference object that you can find in the computer graphics. It is a mathematical model of an ordinary teapot, and it looks very simple, and it is solid in nature, cylindrical, and partially convex. What is convex? See, there are two types of polygons you come across in the model 2 you have studied, right? So, so here, on what basis you define the convex is? If all your points of of the object that you are taking lies within the boundary, then it is called as a concave. Otherwise, it's called as a convex. Now, there are certain functions used in this program. One such function is GL translate. The translate function, why are we using this translate function here? To move the location at a different location, wherein which the exact location will be kept track, like X and Y Z axis. What exactly you are going to look into this is GL translate is used in this program mainly to move your point to different locations. Like for example, initially I want one solid cube at one location, one leg of the table I need. Now I have to move to the another location to make the leg another leg to be positioned of the table, and tabletop I should construct. I should fix some location for placing the teapot. For all this, the GL translate function can be used in this context. The GL, the current, what happens now? This is all theoretical. I told internally how does it works. There is a function, OpenGL function provided, that is called as GL translate f, which takes three axes x, y, z. So here what exactly we are going to do is the current matrix is multiplied by this translation matrix with the product replacing the current matrix. So initially, whenever we apply this, we are loading an identity matrix. That identity matrix is multiplied by whatever the GL translate function, the parameters x and y value you are going to get. With this, you'll be replacing this. This is what. Then there is also another function called as GL scale. This is used to scale along x-axis, y-axis, z-axis, and here also the same thing happens here. What happens? The current matrix. Normally we load identity matrix that is multiplied by your x value, y value, and z value. So this is where your GL scale function is used. Normally we use it for non-uniform scaling. So if you want a different scaling along x, y, z, you can specify it. So this is syntax we have. Next, we are going to use another feature of this program is the light properties has been incorporated. So this is what exactly you're going to have, where you're going to describe a light source, and apart from this, you're making its reflection on the material that you're going to use. For this, we have to set some functions to enable light ring function. Normally in OpenGL, you have to use a function called as GL enable, which is used to enable the lighting, or that is what it is used. Now, in that you can go for shading also you can use if it is preferred by using a function called as shade model. But in our program, we haven't used this. Now, one other very important function we have used in this is GL solid cube. For this, we are specifying the size. Normally, the cube is centered with the model coordinate axis along the sides. GL solid cube and the size. OpenGL presents the programmer with a set of functions. Now, whenever we enable lighting, what is the next step we need to do? In the previous slide, we have looked at how to enable the light. Once you have enabled the light, you need to set the different types of light you want. OpenGL supports different types of light, like ambient is one light source, diffuse, spotlight. Like this, you can use different types of light sources that you have studied in the model. Okay, you have studied in your model 3, wherein which you have studied. Now, in order to enable this, we have GL light model F, and this has totally 4 parameters, or I can call it as 3 parameters, depending on this normally. So light model, whenever we set, we will be setting which light model we want, whether ambient light, that is what is a thing. Okay, so this is all about what exactly we have. Now I'm going to move on to the program. With this introduction, I'll be moving on to the program, the actual program. So look at the program. What exactly you have? You have the first thing that you have is, obviously you have to use glut.h. Followed by this, I'll move on to the main program. So here we have used void main, and the light source that we have used is ambient, or the type of the light source used is ambient. It has 4 parameters, RGBA. Next, we need to set the position for the light, and that's given by 27, 8, 2, 3. Whereas the ambient light that we are taking is white ambient light. All of you can look into that. 111 indicates what? The white. White is a color. So it is white ambient light that is used. What is the unique feature of this ambient? See, ambient produces uniform lighting. So normally in kitchen or in wherever you require uniform lighting, you're going to use ambient light. That is a concept. Next, the position. When you look at the position, X is along 27, Y is along 8, then Z is along 2, and obviously glut init window size, we have given the window size as 700, 700. Next, we have created a window with the title scene, then the function display function. The callback display function is used. Now, I had discussed about this GL enable lighting. So this is a function used to enable the lighting. That is what. Next, there are different types. OpenGL supports totally 8 lights, which starts from GL light 0 to GL light 7. Here, I've used the first light. The first light as what? The first light as the value GL light of 0. Then followed by this, we have set up some of the material properties. Like material properties are basically set for the different phase. In this context, we have used GL front. Front phase is used, and the type of light that we are going to use is ambient based on the value. So here the value that we have specified here is white. So obviously it takes what? White ambient light, that is what. Next, we move on to the GL light FV. So the first light, already I told, here we are using which light? First light. So that is given by GL light of 0. What is the last light? GL light of 7 is the last light. And we have set what? The position. Position. All of you can look into this. GL position. And it's given by an array light pose. So when you move on to this, it takes 27, 80, 2, 3. This is what is a different light source that you are able to find. Followed by this, since it is a 3D object, obviously we have to set up what? The depth test. So it is given by GL depth test. This is what glut main look is, what exactly the function. So this is what is a thing we have. Now I'll move on to the which function? Display function. Let me move on to this. So it's given by the viewport is given GL viewport 00700 700. What it means? We have, what is a viewport? A viewport is a rectangular area of window. When do we use this viewport? Normally, whenever, see, there is a mismatch. Whenever there is a mismatch, see, in your main function you are going to use glut init window size, and next in your display function you will be using glut or GLU ortho 2D the function. So whenever the size, the width and height that you have in your window size and GLU ortho 2D whenever it mismatches, you get a distorted object. Now, how do we overcome this distorted object? We have two options. One is set the value of glut init window size as well as GLU ortho with the same width and height. That is one solution. Another solution is using what is called as a viewport. That is what exactly we have used here. Viewport is a rectangular area of display. So we are exactly mapping whatever the window size we had specified with the same value. All of you can observe this. In the main, we had given window size as what? 700, 700. Here also we have given the same thing. Next, we are going to clear the buffer. What buffers we are going to clear? Clear color buffer bit, okay, and depth buffer bit. So GL color buffer bit is because the frame buffer we are clearing, because we are using a 3D. Obviously, the depth buffer also should be cleared. Then comes the concept of constructing the walls, teapot, table. All this we are going to do here. See here, we have used a user-defined function called as OBJ, which takes totally 6 parameters. Okay, so once the control jump once the program executes the statement, the control jumps to the function by name obj. So all of you are able to see this function obj, right? So here what do we have totally 6 parameters. What are they? Tx, ty, tz, sx, xy, xz. So what does it implies? Tx, ty, tz implies the translation values. That is what. And double x, sx, double s, y, and sz indicates what? The scaling values. Now, what is that we need to do? We need to go for GL rotated. We are using a function called as GL rotated, and wherein which we have a rotating by an angle what? 50 degrees the angle we are going to give, and it is rotating along the y-axis. See, GL rotate function accepts 4 parameters. The first parameter 50 here signifies the theta, means what angle it should rotate. The next question is along which axis. So here we have considered y-axis. So along y-axis it should rotate. That is the concept. Similarly, the next step is we need to rotate by an angle 10 minus 100. GL rotate 11. Okay, minus 1. This is what. Then comes GL translate txt by tz. So after all this rotation, what is the next step? GL translated we are going to give. Then tx, ty, tz. So it takes the value what has been passed 0, 0.5. So only along z-axis it gets translated by a factor of zero point 0.5 and it's going to rotate. Similarly, g scaled, we are going to scale it by a factor. It takes the values. What values it takes? 1, 1.4. So here also we are scaling x-axis by a factor 1, y-axis by factor 2, and the z-axis by a factor 0.004. Zero point zero 0.04, that's what is. Then we move on to the next. After doing all this, we are going to use a function that's provided by your GLAD, that is nothing but GLAD solid cube, and this is what is a function you have, okay, which is going to construct a solid cube. And what the parameter that we should pass is size. So what is the size of the cube, solid cube? It is 1. Then we are loading the identity. See, now comes the question, why did we load the identity? Initially, we have loaded this identity fine. After doing all this operation for the next leg, whatever next wall, whatever we are constructing, it should have a fresh matrix, identity matrix. That is the concept. Now, the next part is we are going to construct the wall 2. 3 walls we are constructing, right? The first wall is constructed. Likewise, it constructs wall 2. So this is wall 2 and this is your wall 3, right? After all this, it moves on to the 4 legs. 4 legs are there. So obviously, how many OBJs should we have? OBJ, this is first leg, this is leg 2, leg 3, leg 4. Okay, we have a walls, we were able to see the walls fine, and within the in front of the wall you have a table. For the table we have put the legs, that is what. Now what else to be put? The tabletop. So that is given by your, this is a function we have used for the table. So all this happens, it goes to the function and it is able to do this. Now after all this, we have to rotate. Now what I'm going to do is, for drawing the wall as well as the legs, we have called a function, the top at the tabletop. Next thing what we are supposed to do, we have to use a function called as glut solid teapot. Glut solid teapot is a function used, and it's something like a built-in function you have. You need to just call this, and you need to pass the size of the teapot. That's enough, based on which it will be able to draw the teapot. Remember here, we used lot number of what is that, GL rotate and translate functions. What exactly they're going to do? They do what is called as GL rotate, and what exactly we are going to have here is 50 0 1 0, 10 minus 1 0 0. This is what we are just rotating that to get it in order to place the solid cube. These are the translation functions. So along x-axis, minus y-axis, and minus z-axis. So in order to fix the proper location for the teapot, you need to rotate along this, and you need to translate it by a factor of 0.3 minus 1 in order to place this. So after all this, finally, a GL flash will make your object to be from command buffer. It will be passed on to the execution buffer, that is called as a network buffer, so that your object will be placed on the graphics. It will be passed to the graphics hardware, and after that also we need to load the identity matrix, because it should not it should not shuffle your matrix. That's all about the program. So after executing the program, this is what is a teapot you are able to get. So all of you can look into this. What do you have here? Three walls, right? We had used this three walls, right? Three obj function we had called. These are for the three walls. Then what did we do? We construct four legs. All of you are able to see the legs of this. Three legs are visible, and one leg is behind. It's very only minute portion of the leg is visible. Then we constructed one tabletop, and at last we placed what? The solid teapot. And for all these objects, the three walls, four legs, and tabletop, what primitive have we used? Did we use any primitive in the program? No, we did not use. But our glut solid cube was able to draw all the three walls, four legs, and tabletop. And for the teapot, we have used glut teapot as a function. That is what. So this is what exactly the program we have. Hope all of you have understood the program. Thank you all.